Action.
Hey everyone, welcome to today's Moledao workshop, which we are holding in conjunction with Polygon. Joining us today is Siraj Raval, Head of Developer Education at Polygon, and he'll be talking to you about NFT innovations with Polygon. So please welcome Siraj today, and we'll go through a workshop on how to use Polygon to create your NFT projects.
Thank you, everybody. Thanks, Alvin. I'm very happy to be here today. Today, we're going to go through a few different concepts in order to understand how NFTs work, how they're minted on Polygon, and what the future of NFTs look like. And we're going to mint an NFT together. All right, so let's get started with a demo, and I'm going to start sharing my screen right now. Okay, so here we have OpenSea. A lot of you may or may not have heard of OpenSea. It's the world's largest NFT marketplace. We can go to OpenSea and we can find a bunch of different NFTs here. These are usually JPEG images that you can buy using Ethereum or other currencies as well. So we're going to go to create, and we're going to create our first NFT right here, right now, in the first 2 minutes of this video. So it's going to ask me to connect to my wallet. My wallet is a place where I store my cryptocurrency, and it's usually connected inside of your browser. I have Chrome, so I have a little icon here for MetaMask, which is my wallet of choice. But just like different apps, whether it's Photoshop or Illustrator, people have a preference for their wallets. So some people might like Coinbase, some people might like MetaMask. It's, they both have their pros and cons. The user experience is going to be different for all of them and their trade-offs. But I like MetaMask because it's been around the longest, and that's pretty much the only reason I use it. And I started using it, and I was too lazy to switch. So that's why I'm on MetaMask. So I'm going to select MetaMask right here, because that's my wallet. It's going to then open up MetaMask. It's a modal pop-up, and it's going to ask me to create my first NFT. So I'm going to go here, and I'm going to get some nice image right here, and we're going to mint that as an NFT. So this is an image of some libraries that you can use to build with Polygon, Truffle, Ethereum, Ganache. So I'm going to name this libraries. And the description is going to be libraries demo. And I can add a bunch of other traits here, but I don't really feel like adding a trait here. Maybe I might want to add some unlockable content. And in that, I can put a link to some secret file that's stored somewhere, like a Google Drive link, like drive.google, or even an IPFS link. IPFS is the decentralized web where files are stored and they are split into many different pieces, and a network of file hosters stores your data. And it's like a decentralized AWS. So we could point it to some IPFS data that's stored there. That could be a ticket. That could be it could be the property to a house. It could be anything really. And so then we're going to mint it. And you can see that Polygon is one of the options here. Ethereum is the first, but then there's Polygon. And the reason that Polygon is an option here is because with Ethereum, it's going to cost money to mint an NFT. It's going to cost actual ETH, which OpenSea is taken care of as a service for us as a third party. But it's too much to allow us to mint a lot, right? But with Polygon, if we were to select Polygon, suddenly the supply text input field is editable, and I can change this number from 1 to however many I want. So with Polygon, right here, right now, we're going to mint 1 trillion NFTs. Okay, so this is 1 trillion NFTs, duplicates of this. We can only do this with Polygon. We cannot do this with Ethereum, and I'm going to explain to you why in a second. But just for now, let's see this magic once it accepts that I'm a human here. Okay, so the maximum is actually, they changed this. This is recent, by the way. I swear this is recent as of today. I was doing this just recently. So we can mint 100,000 of these once I select all the images of the palm trees. All right. That's a lot of NFTs, 100,000 of them. Very fast. That's crazy. Now we can sell these each for 2 Ether and buy private islands with all this money. You never know. It could happen. You never know. So how do we do this? Why could we mint 100,000 of these for free with Polygon, but Ethereum, because it's so expensive, we could only mint one? Why is this the case? Well, if you want to know why that's the case, I have this great link for you called the Polygon Academy. And it's what our team has been working on for a while now. And it's a collection of the best resources from across the web to learn how Polygon works and how to build all sorts of interesting applications with Polygon, not just NFTs, but games and DAOs, DAOs, this decentralized autonomous organizations, infrastructure for Web3. There is DeFi, of course, and all the different things you can do with that, staking. We have all of that here. So you just start at the very top, join the Polygon Academy, and you go all the way to the bottom and you complete it. And I'll say that, over 100 people have completed the first of 4 challenges, and they've gotten their apprentice NFT badge. That these are limited collectible badges that we're giving to students who complete the course. But we go all the way down to the final challenge, and nobody's completed the course yet. So if someone completes the course, please DM me on Twitter, and I'll give you a very special prize. But anyway, this is a good place to learn about it. So just remember the Polygon Academy, because we're going to go even deeper down the rabbit hole right now. But I need you to have a source of truth, a safe place to learn everything you need and come back to. Okay, so back to the original question here. We just minted 100,000 NFTs in 2 minutes for free. How did we do that? So let's see how we did that. So if we go to the Polygon documentation, we have this great image of what it looks like. So Ethereum is in the green and Polygon is in the blue. So the green blocks are the Ethereum blockchain. That's what they represent. And the blue blocks represent the Polygon blockchain. These are 2 separate blockchains. So when we want to mint an NFT, what's happening is a hash ID, a 25-character hash ID is being generated on the Ethereum blockchain that represents some data, whether it's an image or a video or the location of some physical object. Even these ideas of physical digital objects. It points to it and it represents it, and it's like a patent. It's like a patent represents an idea. An NFT is like a digital patent that is global, and it's usually minted on Ethereum. And so when I say minted, inside of these green blocks, that hash ID is located. So your NFT is going to be in one of these green blocks. And because the network is so large, it costs a lot of money to store that data inside of those green blocks. And that's because the people who are actually storing the data in the network, the miners, the Ethereum miners, they need to be reimbursed for all of the transaction processing that they're using their computers to do for the network. And so that's just the way the economic structure is set up in Ethereum. It's expensive to mint NFTs. So what Polygon does is we have a separate blockchain, and you can do the same thing. You can mint an NFT on our blockchain. And when you do that, because our network is architected very differently, which I'm about to explain, when you mint an NFT on Polygon, it's also minted for you on Ethereum. So you paid much less in gas fees, but you essentially still minted an Ethereum NFT. And the reason that it's an Ethereum NFT and a Polygon NFT is because if you look at this image, you have these 3 guys right here. They represent the validators in the network. So Polygon, unlike Ethereum, runs on a consensus mechanism called proof of stake. So instead of validators in the network using their computing power for computing random mathematical puzzles, they are weighted based on they're voting for transactions to be valid or not, weighted on their amount of token that they are hosting at the time. So it's a different consensus mechanism. And those validators are going to send the transaction ID to Ethereum. So it's going to be a message that's passed to Ethereum from them. So you personally don't have to do anything. The network will send the NFT to Ethereum. So it's on both blockchains. So it's a way to mint NFTs on Ethereum for free. That's all I'm saying. And the reason that this works, the reason that it's fast right now is because we have this proof of stake system that I've talked about, but it's going to get even faster. And the way that's going to happen is by us implementing what are called zero knowledge rollups. And I want to explain a little bit about what those are today, because I personally find them very, very interesting here. So there's this idea of the Fibonacci sequence. It is an infinite sequence of numbers. And in this sequence of numbers, all you do is you start at the first number, which can be any number you want it to start with. But let's say that we want to start with 0. To get to the next number, you have to add the previous two numbers together. So the value at any index in the Fibonacci sequence is going to be the sum of the previous two indices. So A plus B equals C, essentially, where A and B are the previous two values and C is the value you're trying to get. So in this case, if we look right here, top to bottom, we have two different lists of numbers, but let's ignore the lists on the right and let's just focus on the list on the left. This is the Fibonacci sequence. We start at 0 and then 1, okay? So 0 plus 1 is 1, so that gives us 3. And then 1 plus 1 is 2, so that gives us 2. 2 plus 1 is 3, so that gives us 3. 3 plus 2 is 5, etc. And that goes on for infinity. Now, on the right, you have the same thing, except the starting number is incremented by 1. And it's the same exact thing. It just starts 1 higher. And this is a really interesting thought experiment for us because this is an infinite sequence that goes on. And this is a way of representing that infinite sequence in a finite way, through this sequence of boxes with numbers in them that represents infinity. And math in many ways is a way of representing infinity very manageably for us. That's essentially what we are doing right now. So there are other ways of representing infinity. In this case, infinity means the Fibonacci sequence. We could write it out like that, or we could write it out like this, which is a relation. It's a set of relations where we represent the rule at every index. It's going to be the sum of the previous two indices. B is going to be equal to A plus B at the previous index. And A is going to be equal to B at that value. And those are the conditions for this infinite sequence. And there's another way we could write it. Instead of just that, we can actually write it out from left to right like that in this array. It's, an array of values that is represented by A and B. There's yet another way we could represent infinity. And this way is called the polynomial format. What the polynomial format is it's a way in math, a standard format of writing out equations where these equations are represented by the sum of powers of exponents multiplied by coefficients. So that's a mouthful. But what that means is that there's a standard format where you have, y equals mx plus b, y equals x squared, y equals x cubed, y equals x to the fourth. You have these exponents that can go up and up and up. Y equals x to the 99th. That's a polynomial as well. This right here, what you're looking at, is also a polynomial. And this represents the same thing we've been talking about, infinity. A equals b of x. A of x equals b of x. B of x equals a of x plus b of x. So these are all ways of representing infinity. All right, so we have this way of representing all of these numbers in a very discrete format. And what we can do is we can do the same thing inside of this image. So we're going to apply the same logic inside of this image. So hold on a second here. Make that bigger. There we go. So on the Polygon blockchain, in these blue blocks, we have millions of transactions that are happening at every second. It's crazy what's happening on the Polygon blockchain. And I want to show you the 10,000 plus dApps that are running, on this blockchain. It's crazy. Like everything that's happening in DeFi, gaming, metaverse, just everything you could ever imagine is happening here. And, this is one of my favorite protocols, Aave, and it's got $22 billion locked in there. That's a lot. That's a lot. And it's a decentralized finance protocol. So imagine all of those Aave transactions, all the $22 billion worth of transactions. And so we have hundreds of thousands of these transactions and we are trying to tell Ethereum, the validators on the Polygon blockchain are trying to send all of those transactions to the Ethereum blockchain so that Ethereum knows there's a record of all those transactions, because we want there to be a finality that is not just on Polygon in terms of transaction clearance, but also on Ethereum. And we could just be sending all those transactions to Ethereum. We could just be sending all of them, but think about it. Nothing is free. There's no free lunch. We would then have to pay for those transactions. And that would mean you would have to pay for those NFTs that you're minting or whatever it is that you're doing. We don't want to do that. We need a more simple way. We need a way of representing infinite transactions over time, finitely. We need to take the continuous and make it discrete. And we need to take this sequence of numbers. It might not be the Fibonacci sequence. It's actually a sequence of transactions. And we need to represent it in a format that Ethereum can accept. So what were the formats that we looked at? Well, we looked at a visual, we looked at an array, but this one in particular, this polynomial format, this would serve us really well, because in the case of blockchains, there's a giant existing literature in what are called in database optimization called lookups. So like in SQL, how do you find some data? How do you look up some data? And polynomials have been used in that literature for a while. And blockchains are actually public databases. So it's kind of similar, except we have this weird consensus algorithm. It's not stored on a single server. And all these different nodes and machines across the world have to agree on every single little value. So that's why this makes it a little different than a database lookup. It's a blockchain lookup. It's still a polynomial lookup where we, as a network, as the Polygon blockchain, instead of giving Ethereum all those transactions, instead of giving them this list of numbers, we're going to give them a polynomial. And that function is going to represent all those transactions. And that function is called a proof. And there are different types of proofs. There's validity proofs. There are many different, Starks and Snarks, and we can go into that, not now, but that's for later, a different talk entirely. But we can fit that. So that polynomial equation represents all those transactions, all those NFTs, all the DeFi, everything. And the reason it's called a zero knowledge rollup is because all of those transactions are rolled up or compressed into a single compressed data packet. And that's that polynomial function. And it's called zero knowledge because Ethereum, when it receives this polynomial, it's going to ask similar to this image right here where there's a prover and verifier. It's going to ask what the identities of the transactions are, because it wants to know whether or not they're valid or not. And it's not going to be able to know that because it's zero knowledge, right? We are not going to give them the identities of the transactions, and that way the users can feel secure that they are remaining anonymous. And so Ethereum is going to guess and check that polynomial function. It's going to try out, as a prover, it's going to try out a bunch of different values. It's going to plug and play and see if the output is equal to what it expects it to be, similar to the Fibonacci sequence. You know that at any given index, I don't even have to know, like at the 4 millionth index, I know how to get there because there's a polynomial that I can use to compute what the value would be at that index. In the similar way, the Ethereum blockchain is going to use the proof the polynomial proof that is generated by Polygon, the zero knowledge proof, to decide whether or not all the transactions are valid or not by guessing and checking a few values to see if the output matches the reality rather than all the values. So it's a much more efficient way of looking up data that is not brute force. And the time complexity, to be very specific in computer science terms, is much more efficient. Right now, instead of n, it would be log of n, and then hopefully someday it would be even better than that. So in terms of programmatic visualization of what this idea looks like, I couldn't really find one because this is such an emerging technology. And, you know, Polygon, we have invested $1 billion in zero knowledge rollup technology. We're very serious about this. We want to implement it. We want, this is the way to scale. But unfortunately, there's not a lot of programmatic examples of what a rollup looks like. So I kind of hacked this little class file together in a GitHub gist, and I call it my little rollup. It's a JavaScript rollup. And it's really just meant to be a learning aid to see what this looks like. So let's go through this together. So it's only 80 lines, so bear with me here. This is a rollup in terms of JavaScript. So just like I was showing you these different ways of representing infinity, I'm showing you different ways of representing data compression. That is what the hottest thing in the blockchain space is today. How do we compress all these transactions that are happening into smaller data packets so that these crazy machines that are trying to agree on everything work well? So this is a function. It's called the rollup function. And we have what are called 4 registers, memory registers. They're all going to be storing different values. And then we have a constructor function called public. In it, we start what's called a Merkle tree. So we create the first what's called root node in the Merkle tree. If you need a visual of what a Merkle tree looks like, we have one right here. It is one of the cryptographic primitives in computer science. It looks like that. It's a tree, and it has parents have child nodes, and it goes on for, it could be up to infinity. So we have this Merkle tree, and we have some memory, and then we're going to define a transaction, who it starts with, where it goes to, how much is in there, etc. And then we're going to create a bunch of transactions in this for loop. So we're going to add some offset to each initial transaction. And so we're going to create a bunch of transactions. So it's like fake transaction data that we're creating. And then what we're going to do is we're going to take all that transaction data and we're going to put it into that tree that we just created. And that tree is going to, I don't have an animation handy, so I'm using my hands. It's going to create branches for all the transactions and linking them all up so they're all linked and they can all be easily indexed and searched and everything. And once it is all in that nice little Merkle tree, it's going to be really easy to create a polynomial, a math equation to represent how to look up all the transactions in that tree. And that's what happens right here is in this function, we create the tree with all that data and we update it and we emit the root of the tree, which is the zero knowledge rollup that represents all of the transactions together. And that is the hottest thing right now in the blockchain space, zero knowledge rollups. It's the reason that you're able to mint NFTs like this, 100,000 of them instantly. And if you're interested in going further down the rabbit hole, then go to the Polygon Academy and start, submitting assignments. I need to see you get to work. And because we have this ecosystem of dApps, but it's just getting started, Where's your dApp? Your dApp is next here. I need to list your dApp on here. So that's it for my talk. Any questions? I'm open for questions. Maybe I need to
Okay. Siraj, so there's one question from earlier. He asked, okay, this guy, Big Cat, he asked, transactions on Polygon are often stuck. How to solve this problem?
Often stop, he said? Often stop?
Stuck.
Yeah. That could be a number of issues. I would want to do a stack trace there. What specifically? It could be the wallet. It could be the network connection. It could be the Ethereum bridge that you're using. So often, if you go to the Polygon subreddit, it's people are complaining about Polygon when it turns out that it's actually Ethereum that is the issue. If you go to the Polygon subreddit, it's like, I can find you one right now where it's like this stuck. Yeah, it's just even searching the word stuck. Watch how many show up here. And then it's always like, 24 days ago. See, like waiting for the checkpoint here. Yeah, it's a bridge. Yeah, it's a bridging issue, whatever bridge they're using right now. But look, I mean, yeah, see the struct. So this was like all happening like 26 days ago. You got to confirm. This is the Wild West, basically. But I would go here to this subreddit, search for stuck, and you'll get some debugging help.
All right, thanks. Okay, another question. Is there any place to generate NFTs on Polygon that is more customized? Yeah.
Let's just like mint free NFT today or something. Like, I think it's like mint NFT.today. It's a Polygon NFT minter. And yeah, so this one.
Okay, cool. So yeah, you can mint like the basic ERC 721 and 1155 kind of contracts. So can you bridge tokens from Polygon to Ethereum?
Yeah. If we go to the wallet, Polygon wallet in the web, it's going to give us an interface into the Ethereum bridge, which we can connect to our wallet. So go to bridge here, Polygon bridge, and it's going to ask, do you want to transfer from Ethereum to Polygon? How much you want to transfer? And it's going to already have connected to your account right now. It's connected to my MetaMask, and I could bridge either Polygon to Ethereum or vice versa, depending on whether or not I want to switch, just like that. And that's how it's done.
Okay. What are some examples of interesting Polygon NFT projects that you have seen?
I would say probably my favorite one would be Avagachi. Yeah, just because it reminds me of Tamagotchi. You can mint these, and it's also that it's very popular as a game. Like, it's actually grown by a lot. So yeah, you can mint these little characters, collectibles. It's done really well. Anything collectible with NFTs does really well. But I love this game.
Okay, can you send us a link to that GitHub snippet that you sent earlier?
Yeah.
Okay.
I'm not saying it works, by the way, but yeah, I'm saying it's a good learning tool. Here we go. I'm going to stop sharing here. Type it in there.
Okay. All right, thanks. So I'll put it in the description. Okay. Right now there are no other questions. I think I think that's all for today. Yeah, thanks for joining us.
Thank you.
Yeah, so and then like I just like to tell the audience as well that we are doing our hackathon. Moledao is doing our MoleHack hackathon, and we are like Polygon is one of our main sponsors as well. So like please come and submit your projects. Like use Polygon as the main network that you're developing on. The gas is much cheaper than Ethereum, and yeah, you can do a lot. Basically anything that you can do on Ethereum, you can do on Polygon. Yeah, so any closing statements, Siraj, like any advice that you would have for people who are just developing on Polygon, starting out to develop?
Yeah, just I guess best way to learn here is to just start running code on your laptop and just opening terminal and just building. That's the best way.
Okay, wait, there's one question that just came in. So what's the difference between optimistic and versus ZK-rollups, and why does Polygon prioritize funding on ZK-rollups?
That's a good question. Yeah. So that difference, it's actually best explained with an image, which I'm trying to find for you. You know, because there's so much going on, and there's one particular image here. It's like a giant table that represents all of the is this, by the way, is this a Chinese speaking audience as well?
No, it's global. Like there's a lot of Chinese people, but it's global.
Okay. Yeah, okay, so here's the link. So I've got a link for you. But yeah, so basically the difference is a trade-off between size. So you get so the size of the payload, and then the cost. So how much, and then, so it's like a space cost trade-off. Yeah. There's a lot there, actually. It's actually, I need to learn more about it too.
Okay. Okay, sure. Again, yeah, let me know in the chat if you can see the image. I'm sharing the screen. So, any other questions? All right. If there are no other questions, then I guess that's all for today. Thanks a lot for joining us, and then check out our Twitter page as well as our website moledao.io. Yeah, and thanks a lot for joining us today.
Thank you.
All right.
Thank you, guys.